Alright, welcome back to Chem 320 Organic Chemistry 1. This is Dr. Russell, and today we're going to talk about acid-base chemistry, actually following up to the lecture that we started on Thursday. So let's get right into it. Let's see what we're going to talk about is deprotonation. We kind of mentioned that in class. The mechanism of deprotonation, which is how it happens, and conjugate acids and bases, and then we're going to spend a lot of time talking about the factors that affect pKa, namely resonance, induction, size, electronegativity, and hybridization state of the atom, where the particular charge is. So let's get into it. Let's talk about deprotonation. Alright, if you remember from class, the definition we gave was just the removal of a proton. Alright, don't forget proton is H plus, so that's taking a hydrogen away without taking the electrons, so the electrons get left behind on the atom that hydrogen was bonded to. Alright, and that happens in a couple of steps. Right, first the base removes the hydrogen, and then the hydrogen leaves behind a pair of electrons. And if you remember from GChem, right, you have an acid plus a base, and that gives you a conjugate acid plus a conjugate base. Okay, so let's look at how this deprotonation works, and I want you to think about deprotonation like a bad breakup. Okay, so here's my acid, right? Remember the definition of a Bronsted acid, it gives up H plus. Here's my base. The definition of a Bronsted base is that it takes or receives, accepts H plus, right? And so the thing about deprotonation that you have to remember is this, right? When the base gives up this pair of electrons to donate here to H plus or to hydrogen, hydrogen has to give these electrons in the bond back to A, all right? So that's very important. It's kind of like like I said, a breakup, right? So A is telling hydrogen, yes, you can leave with B if you want to, but you're going to give me back all those I bought you. I also want that Coach purse I bought you. Everything I ever gave you, I want it back. And so let's look at what happens. So here you see B taking H away from A, those electrons going on to A, giving A a lone pair here. All right, now H and B are bonded together, and A becomes the conjugate base and B becomes the conjugate acid. The conjugate base is what the acid after it loses H plus, and the conjugate acid is the base after it picks up H plus. All right, let's look at it again. Here's my acid, here's my base. The base is taking the electrons. Now I have a bond between B and H. I'm sorry, base takes hydrogen. Now I have a bond between B and H. The bond between H and A is now broken, and those electrons are now on A as a lone pair. Notice A also picks up a charge. So these are some common bases that you'll see in organic. Potassium hydroxide, also a similar basis, sodium hydroxide shown here. Triethylamine is a very good organic base. Notice there's 3 ethyl groups, CH3, CH2, if you remember that from the other day when we were talking about the different alkanes. There are 3 ethyl groups attached to nitrogen here. Very good base. Butylithium is an excellent base. The carbon in butylithium is actually negative, and it works as a base, and it's able to deprotonate. And then tert-butylithium, which is just an isomer of butylithium, also has a negatively charged or partially negative carbon here, covalently bonded to lithium. A very good base. So when you see the B with a pair of electrons, you know, the generic B that I just showed you in the previous slide, you can think of any of these bases as B with a pair of electrons and a negative charge. Alright, so let's look at a real example here. Alright, here's my acid, here's my base. This is acetic acid. It has a pKa of 4.76 and is being deprotonated by triethylamine, which in this case is here. This is my base. Alright, so let's look at the arrows. Alright, again, the base pushes a pair of electrons toward the acidic hydrogen here. The hydrogen oxygen bond breaks, and those electrons go on to oxygen. Right? Now let's watch what happens. You go from acid and base to conjugate acid, which is the base after it pulls off that hydrogen, and then conjugate base, which is the acid after it loses a hydrogen. Notice it now has an extra lone pair and a negative charge. Let's look at it again. So here's my acid, right? Here's my base, and the arrows again are from base to proton, and then from the bond between the proton and whatever atom is bonded to back onto that atom. So let's look at it again. Acid base, now go to conjugate base and conjugate acid. All right, so here's a pop quiz, and you'll get 3 points for each one of these pop quizzes that's embedded within this presentation. Can you draw the conjugate bases for each of these acids if they're being deprotonated by OH minus? So let's see if I can start you off with the first one. So I'll do this plus OH minus. All right, and again the electrons flow here from base to acid, right, and then from this bond between the acid and the proton back down to the atom that the proton is bonded to. All right, and this is an equilibrium. We'll talk about that later. And so what's on the other side of this arrow? Can you draw that? That's a pop quiz for you. All right,